Okay, so vector in physics that will deal with motion in a plane. Motion in a plane. So what we know motion in straight line when something is moving in a straight line, that we know. But when we say motion in a plane, we must have knowledge about the vectors. Okay, now what are the things we should know? Scalar vector, the basic thing, then the position and displacement vector, then equality of vector, negative, equal, co-initial, co-planar, co-linear, unit and zero vector, then multiplication, addition, commutative and associative, subtraction, resolution in 2D. So that 2D is already there in rectangular component, geographical and trigonometric resolution. But what is added, that is 3D part is added. This 3D part is added. And also there is a comparison between the vector addition of 2D and 3D. Then magnitude and direction of the resultant of two vector A, B, that cosine rule and dot product, cross product, all these things are there. Okay. Now the first thing, the scalar and vector. So we'll go through with in a very quick way because we know these things. Like all the physical quantities can be divided into the two main quantities. They are scalar and vector, that we know. And basic difference between them is the direction, because both have magnitude. Only vectors are actually having direction. Okay. And we know the quantities like mass, length, temperature, time, density, work, specific heat. All these are scalar quantity. Scalar may be negative or positive. Scalar can be added, subtracted, like the rule of ordinary algebra, like x, y, z, all these things. But addition and subtraction of scalar makes no sense. Like only the quantities get changed, but the nature doesn't get changed. Hmm. But other thing is that addition and subtraction of scalar makes sense only for quantities of same nature. Like you can do addition, calculation, or subtraction for masses. If you have two mass, if you have two length, if you have two temperature, but it is not like one length another temperature, one time another length. So it will not have any sense, but it will only have sense only if you do it with the same nature. Same nature means either it is mass or it is length or it is temperature, like that. However, multiplication and division can be performed with different quantities. Yes, we do. Suppose we will be doing something like we can multiply mass with length if you want to get a quantity. So that can be done, but subtraction, addition cannot be done until unless they are the same nature. Same nature means same, like masses, or maybe the lengths, or maybe the temperature, like that. And vectors, they are having both the things: velocity, acceleration, displacement, force, momentum, torque, all these things. Even the moment, all these things are vectors. And vectors cannot be added, subtracted, or multiplied or divided by the um, simple rule of algebra. So for that we should learn vector algebra. So vector algebra is different portion in maths, that is there. But vectors what are introduced in physics, that today we'll be discussing. Now, so vector cannot be divided by another vector, as it is not valid operation in vector algebra. But it can be subtracted, multiplied, or added by the rule of vector algebra. Vector quantity obeys triangle law of addition and parallelogram law of addition. Vector is represented as bold face, like in bold letter we have to represent, or we can give an arrow over it. Okay, that also can be done. Okay, because it is very difficult to write it in bold face every time. Okay, now the magnitude of the vector is a scalar part. Suppose you have a vector. If they ask you the magnitude, simply you need to find the modulus of it. We'll see that thing later. Now, position and displacement vector. See, if you want to describe motion of an object over a plane like xy plane, then you need to basically uh, mention its position with respect to the origin. That means 0 0. Okay, so position is very important. Now, suppose you see this is 0 and this 0x is that x axis, 0 y is the y axis. So that means in the Cartesian coordinates, and this is your xy plane. If you consider this plane, that is xy plane, whatever you are seeing in the screen, that is xy plane. Now, if this is a point P, and the position of point P of the object in xy plane at t time, uh, you can, for that, what you should do first, you just join O and P. Okay, you will get a line OP, and basically you have to mention like this, and you have to give the arrowhead towards P, because it basically denotes that it is the distance, or you can say it is the position of the point P, and also it is the distance from the origin O. Okay, now that is R vector. R vector is the position vector. Now this point O of this OP is known as tail of the vector, whereas the point P of the OP is head of the vector OP. So tail is O and the arrowhead is the head. So OP is called position vector. It is represented by R. That means R vector. Now let the object which is on P initially, let it move to P dash or P prime like this. So it basically travels a path A and finally move to this point, this P dash or P prime. Now what you should do, just you basically join O P dash and name it as R dash vector. Then join then OP dash, you name it R dash vector. Then you have to basically find out the displacement vector, because the object or something is getting displaced from this point. This is the initial point to this point. This is the final point. Okay. Now that, for that you have to basically give an arrow towards P dash, and that has to be R dash vector minus R vector. How you will identify? Because it is going to the final position P dash, and that position vector is denoted by R dash. So final, that is R dash vector, minus initial, that is R vector. So therefore R dash vector minus R vector is nothing but the displacement vector. Is nothing but the displacement vector. Okay. Now, okay. Now you can see here another path from P to P dash. Another path is showing the B path, the green color path. Okay. Now see the path is P dash. Okay. So, but it doesn't affect that P to P dash. This P dash might that means R dash minus R. That doesn't change if you follow this new path P dash, this new green path. Okay, so the displacement vector is even same if the object moves through different paths, different course of path from P to P dash. Okay, so infinite number of paths. The position vector of the object provides following information. What are the information they will provide? First one, it gives straight line distance. of the object from the origin. What it will give? It will give straight line distance of the object from the origin. Then it will give the direction of the object with respect to the origin. It will give the direction of the object with respect to the origin. Now equality vector. See, both the vectors should be said equal if they have same direction and same magnitude. Same direction, different magnitude is not the equal. And again, same magnitude, sorry, same direction and different magnitude is also not equal. Uh, and vice versa, same magnitude, different direction is not equal. Okay, now you see this vector O to P. So the vector is A, and again Q to S and vector is B. So more or less both of them are actually having same direction as well as same magnitude, because the length you can assume OP and QS are almost same. Okay, therefore if you try to overlap one vector with other, you can do it because both of them are same. Okay, so both of them are equal vector. Since their head S and P are coinciding, the two vectors are said to be equal. In general, equality is indicated by A vector is equal to B vector. Now here you see this A dash B dash, these two vectors like O dash P dash Q dash S dash. Now here A dash B dash having same magnitude, but they are not equal because they have different direction. How? Because if you consider this is x axis, so this A vector having different direction, and with respect to that x axis it has different direction. So the angles are different. The angle of inclination with the x axis are different. Now even if we shift B dash parallel to itself, so its tail Q dash coincide with the tail O dash. Okay, and the tip S dash or head S dash of B dash does not coincide with the tip P dash of A dash. You can check, it is not coinciding. Okay, now you see here O dash, O double dash P dash, this is the A double dash vector, and here it is Q double dash S dash. Both of them having same direction, they are parallel to each other, but they are not having same magnitude. So what will happen if you overlap it? Still they are not, that S dash and P dash, S double dash and P double dash doesn't coincide, though the O and Q double dash is getting coincide. So vector A dash, A double dash, B double dash have same direction, but they are not equal because they have different magnitude. Few fundamental definition in vector algebra. First, negative vector. So negative vector of a vector is means what? It is the having same magnitude but drawn in opposite direction. See the example. The negative vector of A is A minus A. How? This, suppose this is A. O to P, you see the direction. See the direction of the arrowhead. It is towards P. Now you see another same magnitude vector but in opposite, exactly opposite direction. You see the arrowhead getting changed. Okay, though it is towards P, but the position of O and P getting changed, exactly reverse. So therefore it is negative. If you overlap it also, the things are like the head of one vector is coincide with tail of another vector and vice versa. Now if you add both of them, negative vector and one vector, A vector plus minus of A vector, so you'll be getting 0, because both of them having same magnitude but different direction, opposite direction. Equal vector, if both of them have same magnitude, same direction, then it is equal vector. Co-initial vector, if the initial point like O, origin point of these two vectors A and B are same, so it is known as co-initial vector. Two vectors are said to be co-initial if they have common initial point. Co-terminal if they have common terminal point. Like suppose that P and S if coincide, or maybe the O is getting coincide. So that means from P and S they are basically originating and they are meeting at O. So they are known as co-terminal because it is terminating at O. And both A and B are terminating in the same point, so it is co-terminal vectors. Two vectors are said to be co-terminal if they terminate at a common point. That is the concept. Coplanar, I said earlier, if the vectors are lying in one plane. Suppose the screen of this class, you can see whatever it is there. All these vector whatever I am drawing over the screen are actually coplanar in nature because they are on the screen. So that if I consider this screen to be xy axis, they are on it. So they are all coplanar vectors. So the vectors are said to be coplanar if they lie in the same plane. The vectors drawn in this side are all coplanar in nature. Now collinear. C O double dash P double dash. It is a vector A double dash, and again Q double dash S double dash. It is also B vector, and O double dash P double dash. This vector, and Q double dash S double dash. You see, in the first case, both of them are actually having same direction. In the second case, they are having different direction. Okay, so two vectors having equal or unequal magnitude. So it is not necessary to have equal magnitude for the both the vectors. So two vectors having equal or unequal magnitude, which either act along the same line. See, in the first case, they are acting along the same line or along the parallel lines. They are acting actually parallel lines, but heading along the same point. They are basically parallel lines, but heading along the same point. Okay, but here it is the opposite direction. Now unit vector, a vector divided by its magnitude is known as unit vector. Suppose if I write unit vector of A like this, that would be vector A divided by mod of that. Okay, if A is, you can consider if A is 2I plus 3j minus k, this is the vector. So what will be the unit vector of A? First you write the vector 2I plus 3j minus k, and then the scalar means the modulus. Modulus means square root of I का whole square, I का कोफिशिएंट का whole square मतलब 2 square प्लस 3 का whole square, 3 का ये मतलब j का कोफिशिएंट 3 उसका whole square. Okay, and then k, that means it is having minus 1 whole square, so 1. Now you separate 2i 3j minus k, and here it is 2 square is 4, 3 square is 9, 9 plus 4 13 plus 1 14 root 14. So 2 by root 14 I plus 3 by root 14 j. Okay, and minus k by root 14 is actually the answer in this case, the what I can say, the unit vector concept. Okay, now or a unit vector is a vector of unit magnitude pointing in the particular direction. So it has no dimension or unit. It is used to specify direction only. You see the Cartesian coordinate xyz. That means that OX is a horizontal line in this screen, OY is vertical line, and OZ is something which is basically that means that it is representing the Z axis. So towards the, it is away, it is coming out from the screen. Okay, now if I give along x axis, I can give I because it is the unit vector along x axis. In y it will be j, in z it will be k. Unit vectors along the xy and z of the rectangular coordinate system are denoted by I, j, k respectively. The magnitude of the unit vector is 1 unit and its direction is same as that on the given vector. Only the magnitude is become 1 unit. Since these are the unit vectors, this ijk, so I can say mod of I is equal to mod of j is equal to mod of k, and that is equal to 1 actually. Now zero vectors or null vector. see the vector, like this is the Cartesian coordinate. I can see, consider the two position vector in the plane are shown, like OP and OP dash and OP, that means R dash and R. Okay, these are the two position vector. Now suppose an object which is at P at a time t moves to through P dash. Okay, and the path is PAP and another path is PB, P dash. Okay, then what is the displacement? Displacement is actually, it is that because initial and final position coincide, so the displacement is null vector in this case. So the illustration of the negative vector justify the need of zero vector. Okay, now you see this is OP, that is the A vector. I can denote to the green line, and from that thing the same magnitude if I take, like but in different direction, opposite direction, it is O P dash. Okay, or even sorry, it is also OP, but it is in, if initially it was A vector, then it becomes minus A vector. So they coincide but in opposite direction. So A vector plus minus of A vector is 0. Okay, or you can say, uh, therefore A vector plus 0 is equal to 0 plus A. Okay, therefore it is A vector. In plus we can do that. And lambda into 0, lambda suppose a scalar quantity into multiplied with 0, you will be getting 0 vector. 0 with A vector will give you 0 vector, and then the modulus of 0 vector is 0. Now free vector and localized vector, what are those things? So here in vectors do not have fixed location. Okay, so shifting a vector parallel to its itself leaves the vector unchanged. Such vector is known as free vector. Okay, however in some physical application location of a vector is important. Such vectors are known as localized vector. So two types of free and localized. Now multiplication of vectors by real numbers. Multiplying a vector A with positive number lambda gives a vector whose magnitude is changed by the factor lambda, but the direction is the same as the direction of A vector. Therefore, if the lambda, if I consider a positive number or it is scalar thing, so lambda into A vector is really lambda, that means separated with A vector if A lambda is not equal to 0. For example, if capital A is multiplied by 2, the resultant vector is 2A, is the same same direction as A vector and has a magnitude twice of that A vector. That means if you just multiply 2 with vector A, so it will be 2A now. 2A means magnitude twice. That's all. Direction is the same. Here you see A vector, another green line is 2A vector. So almost twice distance. Now the multiplying a vector A by a negative number lambda. If you multiply a vector, any vector with some negative constant like lambda number, so that will give you lambda A, which direction is opposite to the direction of the vector A. Therefore it is minus lambda into A. So lambda into A is equal to minus lambda, within the bracket it is A if lambda is less than 0. So multiplying a given vector A by a negative number, say 1 or minus 1 or minus 1.5, gives vector as shown in the figure. Now you see your vector A, another in opposite direction, another in opposite direction but 1.5 times. Now addition and subtraction of vectors. In graphical methods we can do addition of vector. Two or more vectors, what you can do, you can add them graphically or geometrically by using laws of vector addition, like triangle law of vector addition. What triangle law says? Simple one only. If two vectors are represented by two adjacent side of a triangle, okay, taken in the same order, then the resultant is represented completely by the third side. If you see that triangle law, this is one side, this is another side contiguity, so third side in opposite direction, that will give you the resultant. Example, a and b both are two vectors. This is a vector, this is b vector. Now to add vector b to vector a, move vector b parallel to itself, like that. Now we can join it. At least the tail of vector b touches the head of the vector a. Join the tail of the vector a and head of the vector b, like this. Join them. Let this be the vector or and r. Or and r. This gives the resultant r, or the sum of the vectors a and b. Like this graphical method is known as head to tail method. Head to tail. So the vector representation. Head means the arrowhead. Tail means the opposite side of it. The two vectors and they are resultant from these sides of the triangle. So this method is also known as triangle method of vector addition. So this is triangle method. Now commutative property of vector. So the resultant vector will be same as if it is um, uh, so shifted to place B. So the value, okay. Then A, B, if two things are there, if we do like this, so that part has to be there. So R vector, if I consider that R vector is equal to B vector plus A vector. A vector is like this, B vector is like this. Now if you add both of them, you'll be getting R is equal to A plus B. So that's so what happens? The resultant R is equal to the both magnitude and direction. Is equal to the both magnitude and direction. Now R is equal to A plus B, or it can be B plus A also. Commutative in nature, na? The above relation of addition proves the vectors are commutative in nature. The property that the vector addition is independent of the order in which the vectors are added. So the property that the vector addition is independent of the order in which the vectors are added is called commutative property. That is what I know. A plus B is equal to B plus A. Now associative property, you need to put the brackets. Suppose A, B both are the vectors. Another C is another vector. Now move B first towards A, towards the this thing, and then move this. So what happens to that? That will happen A plus B. This OQ is equal to A plus B. If you add this thing, and that will be a special geometry, and that part will be according to the polygon law. It will be A plus B plus C. That is A, that is B, that is C. Okay, now if move C towards the B, now that part will be B plus Z. Again move that B plus C towards A, covered. So R is equal to A plus B plus C. Okay, the resultant R is equal to the both magnitude and direction. Okay, now here what you understand, like the resultant R is equal to the both magnitude and direction, like R is equal to A plus B plus C, or A vector plus B vector plus C, like that also that associative law. The above relation of addition proves the vectors are associative in nature. Here also you can see. First you see the first the triangle CB, so that RP is B plus C. Now is consider another one. From there you will be getting another value, then another one, the last one, last triangle if you consider, you will get. Now parallelogram law of vector addition. If two vectors can be represented both in magnitude and direction by the two adjacent sides of a parallelogram, then the resultant is presented uh, completely the same value, both magnitude and direction, as the diagonal of the parallelogram passing through the starting point. So addition of two vectors A and B, if I do it, to add vector B to vector A, move vector B parallel to itself. So that The tail of B will basically coincide with tail of A. So if I do like this, see, now complete the parallelogram. You need to complete it. Okay. So OQRP. OQRP. Draw the diagonal passing through the common point O, and then that will meeting at the tail, and the diagonal represents the resultant of the sum of the vectors, two vectors. Now the resultant is same as the obtained by the triangle law of vector. The same concept you will be getting. The two vectors are represented by the adjacent side of parallelogram, and the resultant is given by the diagonal. So this method is known as parallelogram law of vector addition. Now polygon law, it is something which is multiple of triangle law. So what we can say here in polygon law, if a number of vectors can be represented in magnitude and direction by the sides of a polygon, you can see here, this is the polygon. If I consider from O to P, it is one side, P to Q1, Q to R1. So the closing side is O to R, this side, but it should be taken in the opposite order, not at the same order. This is the order of this, clockwise, but it is somewhat counterclockwise direction. So the closing side of the polygon taken in opposite order will represent the resultant of it. Now the triangle law of vector addition follows from the parallelogram law of vector addition. According to the parallelogram law, OA plus OB is equal to OC. Since parallelogram, the opposite sides are equal and parallel, isn't it? They represent the equal vectors. So you can do OB is equal to AC and OA plus AC. OA plus AC, these two will give you OC, like that. So it is the triangle law of vector addition. Now the subtraction of vectors. Subtraction of vectors can be defined by vector addition of one vector with negative vectors of other. Subtraction of B and A. B is this, sorry, A is this green color, B is like this. Now subtract vector B from vector A, find the negative vector of B. So first we have to get like this. So this is the B. Now display minus B parallel to itself, so that to place the tail of minus B on the head of A. So first like this. Okay. Now join the tail of A to the head of minus B. So tail of A means what? O point, and head of minus B is R point. Join them. Let this be vector OR. This is OR. OR. This gives the resultant R, or the difference between the vectors A and B. So either the addition or the this thing. Now A minus B is equal to A plus of minus B. A minus A is 0. Now the resolution of the vectors. What do you mean by resolutions of the vectors? So the process of splitting up a vector into two or more component. If you are having vector, suppose you are actually having a vector which is having some angle with x-axis like that. So just make two component of this. This suppose it is P, so P cos and then P sine. Now the vectors into which a given vector is split are known as component. So that means the splitted vectors are known as component. The component of vector in a given direction gives the measure of the effect, same effect by the same vector. That means suppose you have a vector, it has two component, ax, ay, in both the direction. So whatever the thing that will give, the same thing will be given by the previous thing. The component of vectors in a given direction gives the measure of the effect of the vector in that direction. Now the rectangular resolution of the vector in a plane. How we will do? Suppose we resolve the vector in terms of I and j. Consider a vector a capital A that lies in plane xy as per the figure. Now this is A. Draw lines from the head of the A perpendicular to the both of axes. Now we get vectors a1 and a2 such that a1 plus a2 is equal to a. Since a1 is parallel to I and a2 is parallel to j, so what we can do? A1 is equal to axi and a2 is ayj. Okay, so the quantities ax and ay are actually called x and y component of the vector A. So a vector is equal to axi plus ayj. Note ax and ay are scalars. Now resolution of vectors using trigonometry. Using simple trigonometry, we can express ax, ay in terms of magnitude of A and the angle theta it makes with the axis x. First, you can see the diagram. You see the vector OA, which is, if we drop the perpendicular from the tip of that vector, it will basically drop on x-axis and in A1 this thing, and in y-axis in A2 like that. So AX is equal to A cos theta, AY is equal to A sin theta. Now the component of the vector can be positive, negative or zero depending on the values of theta. If the theta is 90, if you consider the theta is 90 degree, that means the cos sine component you will be getting, but cos component 0. If I consider theta to be 0 degree, that means the cos component is there, but the sine component becomes 0. Okay, acha. Another thing, a component of vector can be positive, negative and 0 depending on the, so that is what I'm saying. Now if it is 0, theta is equal to 0, so the cos component will be there but sine will be 0. Now we have two ways to specify vector, that is in a plane that can be specified by its magnitude A and the direction theta it makes with x-axis and its component ax, ay. Now if A and theta are given, then ax, ay can be obtained using the above equation, that ax is equal to a cos theta, ay is equal to a sin theta. If ax, ay are given, then a at theta can be obtained. So ax square plus ay square is equal to a square cos square theta plus a square sin square theta. Take a square common, cos square theta plus sin square theta is equal to 1. So a is equal to square root of x square plus ay square. And tan theta is what? This perpendicular, or you can say opposite by base. So opposite was ay, because ay, this part na, this part is ay, this part you see, this is ay. Ay means what? Ayj. Okay, and this part is actually, this is the base part, that is your a. So that is why tan theta is written ay by ax, ay by ax, or theta is equal to tan inverse of ay by ax. Theta is equal to tan inverse of ay by ax. Now moving to the next part, resolution of a vectors in terms of two given vectors. Now let's suppose A and B two vectors are given, but both of them are non-zero. It should be non-zero with different direction, and let A be the another vector in the same plane. Suppose this is A vector, small a vector, small b vector, and that OP is capital A vector. Now capital A can be expressed as a sum of two vectors, one obtained by multiplying A by a real number lambda, another obtained multiplying B vector with another real number mu. Now how to do it? Draw a straight line through O like this. That means through O means on OP like that, parallel to A. Draw another straight line through, that means through O. Okay, and then produce this line B. You see B is produced, small b is produced little bit extended, which will cut the line which is passing through O, and then take the parallel of this B take the parallel line. You can take a help of meter scale and take the parallel line and just draw it like this. So you'll be getting a triangle. Okay, where this part is mu b, this is lambda a. Now what we can do, the vectors oq is lambda a and oqp is mu b. Okay, by triangle law, what you can say, op is equal to oq plus qp, triangle law. So just op is a is equal to lambda a plus mu b. It's very important thing. How to express a vector as a sum of other two vector in the same plane. Similar concept is nothing but you need to draw a triangle with the help of OP and with the other vectors also. For that you need to move the other vectors parallel to them and then make a triangle like that, and so that you can solve it. So the vector A is said to be resolved in lambda A and mu B along A and B respectively. Now resolution of a vector into three rectangular component in 3D space. 3D space. So let us resolve general vector A into three categories like x, y, z, three axes. You know, this is the coordinate x, y, z. Now let us OA is the vector. The angle which makes OA with x-axis is lambda, with y-axis is beta, with z-axis is gamma. Now if we have to draw perpendicular on all these axes, from this, you know, from a vector will draw perpendicular on the axis of x, y, z. Now along x-axis it is axi, along y-axis it is ayj, along z-axis it is azk. Now drop the perpendicular, you will be having this type of 3D view. Now alpha, beta, gamma are the angles between A and X, Y, Z respectively. So AX is equal to A cos alpha, AY is equal to A cos beta, and AZ is equal to A cos gamma. So alpha, cos alpha is equal to AX by A mod. So cos beta is AY by A mod, and cos gamma is AZ by A mod. Now what we should do? What we should do? In generally we know A vector is equal to AXI plus AYJ plus AZK. Now the magnitude of A vector is square root of AX square plus AY square plus AZ square. We know it already. So the position vector R can be expressed as R is also XI plus YJ plus ZK. Now XYZ are the component of R vector along XYZ axis respectively. Now here the alpha, beta, gamma, these are the angles in space. Now they are the angles between the pairs of line which are not coplanar in nature. So and then these angles, so these thing la, this that directional cosine cos square alpha plus cos square beta plus cos square gamma is equal to 1. Same, so the basic concept is nothing but you have this triangle. Why you should do like that is one. You have this triangle. In this triangle, this cos alpha is nothing but this is the base. This is the base by hypotenuse. And similar way here also you'll be having a triangle. Here also triangle in z axis, in y axis also the same thing. So all the causes, cos alpha, cos beta, cos gamma, you'll get, square them, add them, so you'll be having this one value. Now vector addition in 2D analytical method. So graphical method of adding vector is often tedious and basically having less accuracy. So it is much easier to add vectors by combining their respective components. Simple thing. Suppose consider two vectors are there, vector A, vector B in xy plane with component ax and ay, and then bx and by. So vector A is axi plus ayj, vector B is bxi and plus byj. So ax, ay, bx, by, these are the constant term. It can be anything, 2, 3, 4, anything. Let R be the sum, R is equal to a plus b. Now just add them. Then what you should do, commutative and associative both of them. So all ax plus bx is into I, and then ay plus by into j. Since R is equal to Rxi plus Ryj, so you can say Rxi is equal to Ax plus Bxi like that. And so Rx is equal to Ax plus Bx, Ry is equal to Ay plus By. Thus, each component of the resultant vector R is the sum of the corresponding component of A and B. Now, vector addition in 3D. 3D also, if you have these two vectors A and B, you can see, and definitely they are having three things, three directional. Unit. They are having AXI plus AYJ plus AZK. Here also BXI plus BYJ plus BZK. Now add them. Let R be the sum. R is A plus B. R is equal to AXI plus AYJ plus AZK plus BXI plus BYJ plus BZK. Now, since the vectors obey the commutative and associative law, just take x part in one side, like ax plus bx in one side into I vector plus ay plus by into j vector, and then az plus bz into k vector. So this is the associative combination. So again, you can say R is equal to rxi plus ryj plus rzk. So rx is equal to ax plus bx, ry is equal to ay plus by, and rz is equal to az plus bz. Thus, each component of the resultant vector R is the sum of the corresponding component of vectors A and B. This method can be extended to addition, subtraction also for any number of vectors. Let's suppose you have a vector A, B, and C. These are giving A, small a, AXI plus AYJ plus AZK. B is BXI plus BYJ plus BZK. And C is CXI plus CYJ plus CZK. Now my operation is, you need to do a vector, find out a vector T, which is A plus B minus C. So first you add A and B, subtract C, so that the thing will be, just if you see, the tx is ax plus bx minus cx. That means ay is equal to ay plus ty is equal to ay plus by minus cy, and tz is equal to az plus bz minus cz. Okay, so that is how we need to do it. Now you see magnitude and direction of the resultant of two vectors A and B in terms of their magnitude, and theta is the, that means that is the direction actually. So this is the parallelogram law, proof of parallelogram law. Now here you can see the see, this is one vector A, B, and this is A, and this is supposed to be the resultant as per the law says R. Now if you add Q and R as well as P and R, you will get the parallelogram. Now if this angle between A and B is theta, and this is alpha, here also this one is theta. Now look at this small triangle RDP, or okay, we can consider RDP a little bit afterward. Before that, we should consider ORD, the bigger one, ORD triangle. Here what you say, the Pythagoras, OR square is equal to OD square plus RD square. Then see, OD square is what? You see, OD is this. OD is total thing. So OD is nothing but, first this thing is OP plus PD. So OD square is nothing but, what you can say, it is OP plus PD whole square plus RD square was there earlier. Now OP is what? Vector A. PD is B cos theta. For that, I actually first I am considering triangle RPD. In the triangle RPD, if you take this triangle RPD, see the triangle RPD, this small thing, this one. If this is R, this is P, and this is D, this is theta. Now you see cos theta. Cos theta is what? RD by PD. Sorry, PD by RD, base by hypotenuse. PD by RD. PD by RD. PD by RD. Now PD is base. Now PD is what? RD cos theta. And RD is what? RD is what? PD is actually, just a second. PD by RP, not RD, RP. Base by hypotenuse. This is hypotenuse. This is base. PD by RP. So PD, if I want to get PD is what? PD is RP cos theta. Now RP is what? See, Q this QO and RP are the opposite side of this parallelogram. So if QO is B, RP also B. So PD is equal to B cos theta. Similarly, your RD is equal to B sin theta. That is what it is written over there. B sin theta, this one, and this is B cos theta. Now what I say, in OP you write A, and PD you write B cos theta. So OP plus PD, A plus B cos theta whole square, and this RD is B sin theta whole square. Then you expand that A plus B whole square, that thing, A square plus 2AB cos theta plus B square cos theta plus B square sin square theta. Take B square common out of these two terms, and then what you say, this A square plus 2AB cos theta, B square common, cos square theta plus sin square theta, this becomes 1. So you will be having A square plus B square plus 2AB cos theta. Since cos square theta plus sin square theta is equal to 1. Now R square, if R square is like that, so R is equal to square root of A square plus B square plus 2AB cos theta, and you know the direction alpha. Why we should go for alpha? If I look at this angle, this alpha, for the same triangle ORD, this one, this alpha, if I take tan alpha, that will be this RD by OD. So tan alpha is equal to RD by OD. So RD is B sin theta. Again OD is nothing but OP plus PD. So that is B sin theta in numerator, and denominator OP is A and PD is B cos theta. This is how you will get tan alpha. So alpha is equal to tan inverse of that thing. We know the concept. Alpha is equal to tan inverse of that thing. Okay, that concept. And also we have the sine rule, law of sine, that is R by sine theta is equal to A by sine beta is equal to B by sine alpha. And that resultant one is the law of cosine. Okay, so here I am concluding the session.